To simplify radical, we're going to start by finding the prime factors. I like to use the upside down division to do that. And I like to start with the smallest prime number possible. In this case, we can't do 2, so we'll go to 3. 3 times 15, we can do 3 again. 3 times 5. Now that I have my prime factors, I circle any pairs that I have. We have a pair of 3s. So 1, 3 comes out because there's one pair, and then the 5 that's single stays in the radical. Okay, for this example, we'll do 196. We'll do the prime factors. Get 2 times 98. And then 2 times 49. 7 times 7. So there's a pair of 2s and a pair of 7s. So we have a 2 and a 7. And we will multiply those together. Now with the letters, you can write them out just like you do the prime factors. There's 2 pairs of M. And then 3 P's. So there's 1 pair of P's and then a leftover that stays inside. And there's only 1 Q. Another way you can look at the letters is there's 4 M's. So 4 divided by 2 is 2. So 2 comes out. 3 divided by 2 is 1. And there's 1 remainder. So 1 comes out, 1 stays in. And then go ahead and multiply anything you need to. So 14 M squared P, radical P, Q. Okay, we're going to do prime factors of 245. We have 5 times 49, and then 7 times 7. So we have a pair of 7s. There's already a 5 out. Now because of this negative here, we're going to pull an I out. I is an imaginary number that represents the square root of -1. So we pull that -1 out with the I, leaving us a positive in the radical. And then we have a single 5. And then 5 times 7 is 35. Then you have an I, and then radical 5. We'll start by factoring 175. 5 is the smallest prime number we can use. And you get 35. You can do 5 again, and you get 7. So now you have a pair of 5s that come out and a 7 that stays in. There's already a 5 out here, so we need 5 times 5, and then 7. And I left space for our letters. You have 4 H's, so that's 2 pairs, 3 J's, circle that better, there we go. So that's 1 pair and 1 leftover, and then 4 K's to be 2 pairs. So on the outside, you have 5 times 5, which is 25, H squared, J, K squared, and then radical 7J on the inside. Alright, 256. You may know what the square root is. I'll go ahead and show you with the prime factor. So you have 2 times 1, 28, 2 times 64. 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. So there are 4 pairs of 2. So I'm just going to put 2 to the 4th. We do 4 of them. And then the x's, we have 4. And the y, we have 2. So 2 pairs of x, 1 pair of y. Notice there are no singles left over. So we do not have a radical in our answer because there's nothing left that needs to go in there. Now let's simplify this. 2 to the 4th is 16. 16 times 5 is 80. So negative 80, x squared, y. Okay, square root of 196. Which is divisible by 2. You get 98. And I believe we just found the square root a couple problems ago. And you get 7 times 7. So 2 times 7. So 2 and a 7 come out. And then, because of that negative, remember we pull an I out to make that negative out of the radical go away. Because it's mathematically impossible to take the square root of a negative. So we use imaginary numbers instead. Negative 3 times 2 is negative 6 times 7 is negative 42 I.